Whoa. Alright, so 5-4 is where they talk about 5-4 is okay, hello. So when we did integration, we first introduced the integral symbol as purely meaning area. I don't know if you guys remember this. And then it actually took some work to connect that to the idea of antiderivative. So now when I see an integral symbol, I immediately think antiderivative, but they weren't connected at first. They were actually totally separate ideas. So 5-4 comes in and says, forget about area shit, let's just talk about antiderivative really. Number 4. Ooh, yummy. Okay, good. I love it. This is beautiful. This is the one. You gotta love this shit. This one gives you this integral. It does not say evaluate the integral. Thank the gods. Right? Do you want to evaluate the integral? Some of you, I would hope to say, you would say yes, and maybe you did. But all this says is verify that this equals this. Lord, 3bx plus 2. A equals bx to 3s. Plus. That is yummy shit. Now, do you guys understand? This problem is not asking you to do this integral. It isn't. It's saying verify that this equals this. How do you do that? Take the derivative of this. It better come out to be this. That's the whole idea, right? This is the antiderivative. So if the antiderivative of this is this, then the derivative of this must be that. And taking derivatives is always infinitely easier than integrals. Not infinitely. Is that cool? Is that right? How do you take this guy's derivative? What's the variable? What's the true variable here? X. So that's a constant. There's X. There's X. So it's a, what kind of rule? Product rule. Yeah. It's not the prettiest looking thing, but the actual steps you got to take are easy. Now, some of the simplification to make it look like this might get interesting. I don't care. But that's stuff you can sink your teeth into. And maybe, is that cool? Is that all right? What's up? Yeah. Yep, okay. Anything else from homework stuff? No. Okay. All right. I'm an optimistic fool. Assume that means homework's going great. All right. So let's get back into what we got into last time. So, I think I just barely talked about the idea in 6.1, which was the idea of finding areas between any two curves. You could do it, the problem can come at you in one of two ways. So we'll look at it both ways. That's going to be a neat part.